Good evening, everyone. So, welcome to my YouTube channel, Math Doctor. So, today we are going to see third lecture on direct products. We were studying external direct products. So, we will continue our lecture. So, we are going to prove another important result theorem. If G1 and G2 B groups, then first is G1 E2 intersection E1 G2 is equal to E1 E2. Okay. It means what does it mean? It means the identity is the only element identity is the only element common in G1 E2 and E1 G2. Okay. Second, every element in G1 partition E2 commutes with every element in E1 G2. Okay. Third one is every element of G1 Cartesian product, it means it is external product, can be uniquely expressed as the product of an element in G1 E2 by an element in E1 G2. Okay. fourth one is G1 external product by G2 is isomorphic to G2 external product by G1. Okay, these are isomorphic to each other. So let's prove this result of theorem. So one, let G1 H1 belongs to G1 E2 intersection G1 G2. Then what we have? So this belongs to intersection. So it belongs to this one and this one also. So it belongs to G1. Okay. And G1 H1 belongs to G1 G2. Okay. Now G1 H1 belongs to G1 G2. So this implies, because this belongs to this one, so H1 will be equal to E2. H1 will be equal to E2. Okay. And G1 H1 belongs to E1 G2. This implies G1 is equal to E1. Okay. Therefore, G1 H1 is equal to G1. Okay. It means, what does it mean? It means that you take any element from their intersection, it turns out to be E1, E2. Okay. But E1, E2 belongs to both elements, both the subsets. So this implies G1 E2 intersection E1 is equal to E1 E2. Okay. So you take any element from intersection, it turns out to be E1 E2. And we know that E1 E2 actually belongs to this intersection. Okay. So what is the intersection exactly? Exactly intersection is this one, E1 E2. Okay. So in place of, therefore you can write, use this symbol. Okay. Now second part, we are going to prove second part. So first part is proof. Second part is, let G1 E2 belongs to G1 E2 and E1 G2 belongs to E1. We have to show that both the elements converge. Okay. Now What is G1, E2, E1, G2? This is nothing but G1, E1, E2, G2. So what is this? This is G1 and this is G2. And we can write same thing as E1, G1 because E1 is identity in G1 and E2 is identity in G2. Okay. Same thing we can write like that. So what is this? This is E1, G2. Okay. And this is G1, G2. Okay. So we got G1, G2, G1, G2 is equal to G1, G2, G1, G2. Okay. So each element, so this implies each element in G1 Cartesian E2 commutes with each element in E1 G2. Okay. So third one we are going to prove. Second is proof. Okay. Now we have to show that in third that each element of G1 cross G2 can be uniquely expressed as a product of one element in G1 cross G2 and one element from E1 cross G2. So let G1 G2 belongs to, okay. Then G1 belongs to G1 and G2 belongs to. So this implies G1 G2 belongs to G1 G2 and E1 G2 belongs to E1 G2. Now we have G1 G2. What is this? What is the product of these two elements? G1 G2 and E1 G2. What is this? This is nothing but G1 E1 G2 G2. What is this? G1 G2. Thus G1 G2 can be expressed as a product of a member of G1 Cartesian E2 by a member of E1 E2. Now this product is unique. We have to show uniqueness of product. product. Product is unique, so we are going to show uniqueness of product. If possible, let there be another representation. Representation means we have another two elements whose product is G1, G2. It means H1, E2 belongs to G1, E2, and E1, H2 belongs to E1, G2, such that G1, G2 is equal to H1, E2, E1, H2. Then what is this? Then what will be this? Okay. This implies G1, G2 is equal to H1, E1, E2, H2. So what is this? G1, G2 is equal to H1, H2. So this implies G1 is equal to H1 and G2 is equal to H2. Okay. Therefore, G1, H1, E2 is equal to G1, E2 and H2 and E1, H2 is equal to E1, G2. Okay. Okay. So this implies the representation is unique. Okay. So representation is unique. Now in fourth part, we have to show that G1 external product by G2 is isomorphic to G2 external product by G1. Okay. So define a mapping. Define a mapping phi from G1 cross G2 to G2 cross G1 by phi G1 G2 is equal to G2 G1. Then number 1, phi is 1, 1. Let G1 G2 and H1 H2 belongs to G1 partition G2. Okay. Such that phi G1 G2 is equal to phi H1 H2. Okay. Now phi G1 G2 is equal to phi H1 H2. So what is this? This is G2 G1. Okay. And what is this? This is H2 H1. So if we compare both the side, what will be G2 will be H2 and G1 will be H1. So this implies G1 G2 equal to H1 H2. Okay. So this implies phi is 1. Second, phi is on. Let G2 G1 belongs to G2 partition G1. Then G2 belongs to G2 and G1 belongs to G1. So this implies G1 G2 belongs to G1. Okay. And phi G1 G2 is equal to G2 G1. Okay. So given G1 G2 G1 G2 G1 belongs to G2 cross G1. We have G1 G2 belongs to G1 such that phi G1 G2 is equal to G2 G. So this implies phi is on. Third one is phi is homomorphic. Okay. So phi is homomorphic. So let G1 G2 belongs to G1 G2 and H1 H2 belongs to G1 partition G2. Then phi G1 G2 H1 H2 is equal to, what is this inside him? This is nothing but G1 H1 G2 H2. Okay. Now what is the definition of phi? So it will flip the elements, change the coordinates by interchanging the coordinates. So we can write it G2 G1 H2 H1 phi G1 G2 phi H1, H2. So this implies phi G1, G2, H1, H2 is equal to phi G1, G2 phi H1, H2. This implies phi is homomorphism. Since phi is homomorphism, 1, 1 and on to on to on to, we conclude that phi G1 cross G2 to G2 cross G1 is isomorphism onto. So isomorphism onto means what? So this implies G1 G2 is isomorphic to Cartesian G1. So it means what? G1 Cartesian G2. It means external product of G1 by G2 is isomorphic to external product of G1 by external product of G2 by G1. So this is true. The theorem is completely proved. We have proved all 4 parts. So today's lecture is this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my channel. Thank you very much for today's lecture. Thank you very much.